Hey everybody, welcome to the Fall Final Test Review, Part 1. We are not going to do every single problem on this review, but we're going to do quite a few. Before beginning, I recommend having a brain dump, or what we call like a kind of a color-coded periodic table just to help you out. A periodic table with the polyatomic ions on it, or a list of your polyatomic ions, and also an electron configuration periodic table. That's the one that had the trends on one side with the arrows and the blocks on the other. So let's go ahead and get started, and we're going to go with number 2. I'm going to start with number 2. And it says, what does the atomic number represent? Okay, so on your periodic table, you're going to see these numbers that up at the top. And it even says on this one, atomic number. That is representative of the number of protons. So protons is our answer. That's protons. And a neutral atom, that will also represent electrons. So I'll also do number 3, just so we can see. So in a neutral atom, and we're going to look at fluorine, okay, because that's what this question is asking. Fluorine, its atomic number is 9, so in a neutral atom, we're going to assume that fluorine has 9 protons as well as 9 electrons, okay? 9 and 9. Now, as far as this number down here with the fluorine, this number right there, that 18.998, that is the average atomic mass. So that is not the number of neutrons. In order to get the number of neutrons, we're going to do our little ape man, right? So the man part of ape man is how we will figure out, if you think about ape man, the man part stands for the mass minus the atomic number, or the number of protons, equals the neutrons. Okay, so for fluorine, the mass, we're going to round up to the nearest whole number, so we're going to round that up to 19. I'm going to take away 9, and that will give us the neutrons. So 19 minus 9 is equal to 10 neutrons. Okay. So let's go to number 5. What is an isotope? So I'm not going to give you the 100% scientific definition. I'm going to keep it as simple as possible, but most simply speaking, atoms can have all kinds of different numbers of neutrons. For example, this lithium, sometimes it could maybe have 3 neutrons, sometimes 4, sometimes 5. So that variations in neutrons are known as isotopes, okay? So it's very unscientifically, it's just basically variations in neutrons, okay? Variations in neutrons. So when the neutrons, and this, almost every single element has lots of naturally occurring isotopes, okay? Neutrons. Changes in neutrons. Let's do number 7. What 2 subatomic particles can be found in the nucleus? So what is inside the nucleus? that is going to be, of course, the neutrons. Sounds like the word nucleus, right? Neutrons. And also the protons. What charge does the nucleus have? Well, neutrons have no charge. Protons have a positive charge. So overall, the nucleus is positively charged. Okay, and we just talked about number 9. Isotopes of the same element have the same number of protons, but a different number of neutrons. So the next one, 10 through 13. I very strongly recommend that you have a periodic table labeled before you begin your final, before you take your final, that has all of these written out. Okay? I made it on a little brain dump one, and I recommend you do the same, right? So I labeled them all for myself, so it makes answering numbers 10 through 13 very quick. The halogens are found in group or family. So I'm going to go look where I wrote it down. Okay, there it is, halogen. That's group 7A or 17. The next question says, I would really very strongly encourage you to make something similar. Okay, so really, and I will actually back this up and let y'all all take a look at that. Maybe pause your video if you're watching at home or in class. Pause it. Make something like this before you take your test. It just has all kinds of, I'll take it out of this shiny thing. This brain dump is very helpful. I just wrote down some very essential things. I would especially color out where your transition metals are. Color out your exception block. I colored this block too because these are our metals with a set number of valence electrons. Label those valence electrons. Label those families. So these are the alkali. This is alkaline earth in number 2. Halogens, even though I wrote it small, halogens. And then you've got your noble gases here. So if you want to pause it, write something like this, make your own, it's very helpful. Okay, that makes problems like 10 through 13 very quick work, right? And I guarantee you there will be a lot of questions on the test. If you make something like this, you'll be able to have the answers right there. Okay, so we're going to keep going. I'm going to go with number 15. It says, we're in this isotopes and ape man section. So ape man, we wrote already what the man part stood for, but the ape parts, ape, that stands for atomic number is equal to the protons and electrons. And once again, the atomic number is, if you're looking on a periodic table, we'll use the little one I made, this number up here. Okay, that's your atomic number. Now, when it's written like, I said we were going to do number 15. When it's written like this and you see the big number on top, then you know it's in isotopic notation. So that just means the atomic number then is on the bottom, whereas when we see it in the periodic table, it's on the top. They just flip it when they're doing isotopic notation. And I actually think this is helpful because it makes it really easy to subtract out. Because remember how to get the neutrons, you have to subtract? Well, when it's written this way, it's really easy. It reminds me of how you learn in elementary school to do subtraction. Like all big and nice, just like that. So it's really easy to do the subtraction and see, oh, it's got 6 neutrons. Because atomic number is equal to protons and electrons, we know that there are 4 protons, 4 electrons, and then 6 neutrons. So I'm going to find that choice. Okay, so we want 6 neutrons, 4 protons, 4 electrons. Okay? And I think that's a pretty good amount of these. We'll do one more. We'll do 17 as well. Okay. Once again, this number here, I'll label that for you. This is the mass on top. When it's written with the bigger number on top, you know that's the mass. This is the atomic number on the bottom. And that is equal to your protons. I'm going to write a P. And your electrons. Okay? So it's asking about my neutrons. In order to get the neutrons, I need to subtract. So I'm going to say 108 minus 55. Now, I don't mind. I actually encourage you to use a calculator for everything in here. I am not testing you on your abilities to do mental math. So if you want to use a calculator on even what might be considered an easy problem, I encourage you to do that. It'll make it faster because remember, your final will be timed. So that answer was 53. 53 neutrons. All right, number 18 is very important. Elements with similar chemical properties are found in the same group or family. Group and family are the same thing. On my brain dump periodic table, I wrote group. Last 2 letters are UP. That helps me remember that groups go up and down, up and down. Okay, so the reason this happens is because of number 19. Atoms of elements that are in the same group, okay, have the same number of valence electrons. So our valence electrons are the same in our groups. Well, not the transition metals, but in these groups. Valence electrons. All right. Let's keep going. Okay, I'm going to work out number 20 for you. It says calculate the average atomic mass, then use the periodic table to identify the elements. Okay, so here is what we have, a little instruction box, but really what you're going to do here is I'm going to show you in steps. So I'm going to set it up first. Use parentheses when you do it in a calculator. This will help you avoid making errors. Okay? So in a parenthesis, I'm going to write 27 times, and I need to change this right here to from a percent to a decimal, and this is really easy actually. You just have to move it over where your decimal is. Move it over 2 places. 2 places. So it's going to be 27 times 0.9223 plus, I'm going to do the same thing now for 28. I'm going to say plus in a new parenthesis, 28 times, again, you need to move it over 2 places. So for that, you need to really be careful with that one because students have a tendency to just put 0.4, but that's actually 40%. So you got to include that 0.0467 plus new parentheses 29 times, again move it over 2 places, 0.031, and then you're going to hit equals. If you do it all in parentheses, you can do it in one step in your calculator. But if you don't use parentheses, you're going to get an order of operations problem. It's not going to work right. So be sure to use those parentheses. So 27 times 0.9223 plus 28 times 0.0467 plus 29 times 0.031. That gave me an answer of 27.1087. Okay, and that makes sense because the most abundant is the one with the mass of 27, so it makes sense that the answer is going to be pretty close to the most abundant one. So that is my answer. I'll write that in a different color. 27 points. Okay. All right. Octet rule just means that atoms will gain or lose electrons. In order to have a full shell on their outermost valence. So their outermost electrons, they want it to be full, and for the very majority of elements, with a couple of exceptions, that's 8. So octet is 8. So they'll gain or lose electrons. The metals will lose them. The nonmetals will gain them in order to have a full valence shell. Gain or lose electrons. Atoms will gain or lose electrons in order to have a full valence shell. Okay, we've already talked about the vertical columns. Those are our groups, right? But we have not talked about the horizontal, the ones that go across. Those are called periods. Okay, so those are periods. And they tell us the number of energy levels. So periods, they go across, and those tell you the energy levels. And we already talked about how the vertical ones are the groups, and they'll tell you the valence electrons. Okay, so let's skip down to a few. I'm going to go to 24. The least reactive group is the noble gases. And that goes back to our octet rule. Noble gases, they have 8 valence electrons, which is a full octet. It's a full octet of 8. So there they are, noble gases. So they're not very reactive because they don't want to gain or lose anything. Okay, let's see. Let's go to number 30, because I actually think this is an interesting one as well. It says, what element has the same number of energy levels as phosphorus? And this is a bit of a typo because actually it should say you can answer more than one of these is correct. The same number of energy levels as phosphorus. So that means something in the same period going across as phosphorus. And there are actually several. There's only one that is not correct on this list. So here is phosphorus, and our choices are silicon. Yes, that's in the same one. Argon. That is also in the same row going across. And arsenic, that is in the same group. So that one is not correct. So all of these actually are correct except for arsenic. Okay, arsenic has the same number of valence electrons because it's going up and down. Right? So here's arsenic, it's going up and down. That's the same number of valence electrons. Going across, they're in the same period, and that gives you energy levels. Okay, I'm going to go to number 32. Which subatomic particle has a negative charge? That is an electron. They are negatively charged. Protons are positive, neutrons are neutral. And now I'm going to go to number 34. What element is represented by the Bohr diagram? Now, these are actually really easy because if you know the number of protons, you know what element it is. So I just need to find 20 on my list, and there it is. There's the 20. So that's calcium. Protons give it away every single time because neutrons or electrons can vary, but protons are what makes that element that particular element. So something, if it had 19 protons, for example, it would not be calcium, it would be potassium. If it had 21, it would be scandium. But because it has 20, I know it is calcium. Now the mass number for this, you don't want to use the average atomic mass, okay? Average atomic masses average out all the different isotopes, and that's why we end up with a long decimal. But if you know for sure the number of neutrons, you just add them together to get the exact mass. So I'm going to say 20 plus 20, and that is 40. Okay, and how did I know? I added together the protons plus the neutrons. So mass is equal to protons plus neutrons. Okay. Now we want to know how many total electrons. So again, if you think about 8-man, right? The protons and electrons are equal in a neutral atom. So I know for sure it's got 20 total electrons. And if I look, I can find the number of valence electrons in two different places. If I want to, I can just count these two outer dots. There's 2. Okay, those are the valence ones because those valence ones are the ones on the very outside. Another way you can tell is because of this 2 here. Okay, that'll give you the valence electrons. So it's got 2 valence electrons. All right, let's keep going. Okay, I'm going to do number 37. It says, which electron dot symbol represents the noble gases? Okay, so I am going to want to find one that has 8 dots because each dot represents a valence electron. And if you remember my little picture here, here's my noble gases. They have 8 valence electrons. Okay? So I just want to look for one that has 8 dots. And you can count. That's not 8. There we go. So it's that one. Okay, and now I'm going to do the same thing for number 39. Which group or family is represented by this dot structure? I see 1, 2, 3 dots. Okay, so here is something tricky. The reason we colored all this green is because these are our transition metals. So we don't want to say it's in 3. These have varying numbers of valence electrons, so it's nothing in here. We need to move to the other side of the periodic table where it says 13. These have set valence electrons. So when you're talking about valence electrons, you don't want to use your transition metals. You want to use the 13, 14, or if you want to look at the A column. Okay, so it's going to be C. Okay, and it says, how do I know? Because I see 3 dots, which means 3 valence electrons. That's our group 13. All right, moving along when an atom loses one or more valence electron, it is called, and it's saying cation or anion. And I wrote on my my brain dump, cations, I wrote cats lose lives. So I always told my students, okay, think about cats, and this is very silly. So I always tell them metals go meow. That's how you can remember their cations. And cations have a cat has little paws, so they have a positive charge, right? And then I told them to say cats lose lives, because remember cats have 9 lives, so lives to lose. So they lose their electrons, they have a positive charge, and they are metals. Okay, so when it loses, it is called a cation. Okay, and they have a positive charge. Think about little cat paws. Or you can think about the T in the middle, like a plus sign. All right. And I'm going to go to 42. And it says, ionic bonds form between what kinds of elements? That would be your metals plus your nonmetals. And I wrote that on my little brain dump too. It says ionic, metal plus nonmetal. So, metal and a nonmetal. What happens to their electrons in an ionic bond? They are transferred. So the metals want to get rid of their electrons so they can drop down to the valence electrons, and the nonmetals want to pick up electrons so they're transferred. The electrons are transferred from the metal to the nonmetal. Okay. I am going to go to, let's see, 47. It says potassium would likely form an ion with what charge? So when potassium, you want to think about what potassium wants to do with its electrons. Potassium is a metal. And remember, cats lose lives. It's a cation. So that potassium wants to lose an electron. When that happens, potassium will now have more protons, which have a positive charge. One more proton. It only has one valence electron, so it's going to want to lose one of those electrons, which will give it one more proton. So we'll have a positive 1 charge. Nitrogen, on the other hand, nitrogen wants to gain electrons. And I told my students they can remember that because onions have layers, right? So if you cut open an onion, it's like you've gained all these layers. They're gaining electrons. If you gain something that is negatively charged, that's why there's negative. Students sometimes are very confused because they're like, what? It's gaining. Why is it negative? Well, it's negatively charged. So when nitrogen forms an ion, it's going to want to pick up 3 electrons from a metal or from a few metals, depending on the situation. And that will give it 3 more electrons and a -3 charge. Okay, so we've talked about 49 and 50 quite a bit. So I bet you can answer that now from what we've been talking about. Okay. So I'm going to flip over to page 4. Actually, well, I'll do 49 and 50 because I think they are important. Metals tend to lose electrons and form cats lose lives. They're positively charged. Positive, not anions. Positive cations, cats lose lives. Metals tend to lose electrons and form positive cations, while nonmetals tend to gain electrons. Okay, they gain, onions have layers, and form negatively charged anions. Okay, now we'll go to the next page. Now for this page, you're going to need this chart right here, your electron configuration periodic table. So take that out. If you need one, they're on Canvas from Unit 2. So it says, what is the noble gas notation for nickel? First you want to find nickel. Nickel is right here. Okay, and then we want to think about what noble gas is nickel closest to without it being larger. So krypton is number 36, that's too big. We're going to use argon because it is smaller than nickel. So we're just going to go from there. We're going to put argon in a bracket. Okay, so argon will go in a bracket. That's how we're going to start our configuration. So it's going to be AR, and then we're going to go from there and finish off the configuration. So we'll start over on the other parts, on the other side from 18. We're going to start at 19. So I'm going to say 4s2 because I haven't gotten to nickel yet. 3d, and then I'm going to stop when I find nickel. 3d8. So that is our noble gas notation. It is 4s2, 3d8, which is C. Okay, let's do number 54. Okay, look at if you ever have a configuration, you can look at the very last one, and that will tell you. I always tell my students, think about it like an apartment, and I say, who lives in apartment 2p3? So think about it like battleship. 2p3. That is nitrogen. Okay, so nitrogen. That's nitrogen. And then nitrogen, okay, is in groups go up and down, group 5, okay, up and down, 5A, and period 2. Group 5A, period 2. Okay. So always just look at that last one. So now I'm going to do 58. It says, what group on the periodic table does this valence orbital notation represent? Don't panic, just count the arrows. 1, 2, 3, 4, 5, 6, 7. There are 7 arrows. So that's going to be group 17 or 7A. Okay? No problem at all. Okay, next part says, fill in, well actually we're going to go to the trends. This is going to be on the other side of your paper. Okay, so flip over your blue chart and go to the one with the arrows. Okay, so for these we're going to compare. We're going to look at our trends. The first one we're going to look at is for the trend of ionization energy. And out of sodium, chlorine, silicon, and magnesium, we want to find the highest. So I recommend just getting a clear sheet or just making little dots with your pencil to make it really easy to compare. So sodium, chlorine, or silicon, and aluminum. So what you want to do is just let the arrows be your guide. Ionization arrow is pointing up towards helium. You want to find the one that's the closest to that of the ones you marked. That would be chlorine. Okay, so chlorine. And then same thing for all the trends. They all kind of work that way. So I'm actually going to go back and do 62. This one is looking at atomic radius. Okay, so atomic radius, so you want the one that's the closest to francium. Closest to francium, so once again you're going to mark your page. You want to get the closest to francium. I've got boron and gallium and aluminum and indium. So the one that is closest to francium is indium, because that's where those arrows are pointing. Okay. Same thing with electronegativity. You just look, where are your arrows pointing? Electronegativity, you want the one that's closest to fluorine without going past it. Okay, because these have no electronegativity. They don't want any more electrons. So the closest to fluorine without going past it from the choices: sulfur, oxygen, tellurium, and selenium. Okay, which one is the closest to fluorine without going over? Oxygen's right next door. It's very close. So I'm going to pick oxygen. All right. So that was a good amount of problems, and I will see you in part 2. Great job.